In the previous video, we discussed how to value stocks using a constant growth model. Here we're going to look into another model to value stocks, the non-constant growth model. The two different models can be used to value two different types of companies. Take for example Stablecorp here. Notice that Stablecorp is a growing company. Its net income is increasing each and every year. It's growing, however, at a steady, constant rate. This is illustrated by the steady slope of the line here. Stablecorp could represent mature, predictable companies, a company like Coca-Cola, for example. For a company like this, we could use the constant growth model to value its stock. Startup Corp is also a growing company. Its growth, however, is not constant. Look at the steepness of the slope in the early periods. That's indicative of rapid growth in those years. Then by 2026, growth steadies and Startup Corp appears to grow at a constant rate. So from now into the future, its growth is not constant. As a result, we would use the non-constant growth model to value it. Startup Corp would be representative of new, innovative companies that come into the market, and we can look at their growth in the context of a company's life cycle. Let's assume a company has two parts to its life. In the first part, it grows very rapidly. We'll call this the supernormal growth period. This could be like a startup company with an innovative product rapidly gaining new customers. As a result of this rapid growth, its dividend could be growing at a quick pace too. The next part we'll call the horizon period. In this area of the company's life, its growth stabilizes. It doesn't gain new customers as extensively as the early periods. Maybe the industry has new entrants, so it's much more competitive. In this part, growth stabilizes, and similarly, the growth rate of dividends becomes stable. We can define the start of this period as the horizon date. This is a date in which the growth rate of dividends becomes constant. To value a non-constant growth company like this, we'll have to look at these two periods separately. We'll first find the value of the cash flows in the supernormal period, and then find the value of the cash flows in the horizon period. We can use a four-step recipe to value a non-constant growth stock. The first step will be to determine the horizon date. That is, determine the point in time in which the growth rate in dividends becomes constant. The next step will be to determine the size of each dividend up to that horizon date. What dividend will the company pay next year, the following year, etc. We'll need to do this for each date up until the horizon date. Third, we can apply the constant growth model at the horizon date to find the horizon value of the stock at that date. The reason we can do this is because at this point we meet the requirements to use the constant growth model. The growth rate of dividends will be constant, and the required return, R, will be greater than that constant growth rate, G. This will become more clear once we look at an example. Lastly, to find the value of the stock today, we'll just find the present value of all the future cash flows. That will be the present value of the dividends up to the horizon date and the horizon value. Now that we know the steps of the recipe for valuing a non-constant growth stock, let's try to use it. Say we have a company that's expected to increase its dividend by 20% in 1 year and by 15% the following 2 years. In the years to follow, the dividend will increase by 5% each year. If the last dividend was $1 and the required return on the stock is 10%, what is its value? We can start by drawing a timeline. I think drawing timelines is important for all circumstances, but it's especially important here to make sure we keep the timing of the cash flows tracked properly. We have information on the current dividend, that's D0, and some incomplete information on the next three dividends, D1, D2, and D3. We don't know what the size of those dividends are yet, but we can find them easily using the growth rates that are given to us. We know the current dividend is $1, and it will grow by 20% in 1 year, and then by 15% the following 2 years. Then, the dividend will grow by 5% the year after that, and by 5% the year after that, forever. Looking at this timeline, we can identify the horizon date. Remember, the horizon date is the date at which the growth rate of dividends becomes constant. And at year 3 here, the growth rate becomes constant. Starting at year 3, the growth rate will be 5% each year forever after. That means we need to find the size of the dividends up to the horizon date. That is D1, D2, and D3. So let's start figuring out those dividends. D1 is going to be 20% bigger than the current dividend of $1. So we can get D1 as 1 times 1 plus 0.20. And that gives us $1.20 for D1. The dividend at time 2 will be 15% bigger than the dividend at time 1, which we just found to be $1.20. So we can find D2 as $1.20 times 1 plus 0.15, or $1.38. And D3 will be 15% bigger than D2, so $1.38 times 1 plus 0.15, or $1.59. And now we've computed all the dividends up to the horizon date, year 3. Next, we have to find the value of the stock at the horizon date. We can get the value of the stock at year 3 by taking the next period dividend and dividing by the required return minus the constant growth rate, where the constant growth rate is 5%. We didn't compute D4 yet, but we can rewrite the formula in terms of what we already know. D4 is just going to be G% bigger than D3. So we can say the value of the stock at year 3 is the dividend at year 3 times 1 plus the constant growth rate divided by R minus G, where R is the 10% required return. Putting in our numbers, we get $33.39. This is the value of the stock at year 3. And let's pause for a second to think about what this number, 3339, means. 3339 is the value at year 3 of the dividends to be received in year 4, 5, 6, and every year after. I'll put the 3339 on our timeline, and now we can do the final step of our recipe. We need to find the present value today of all the future cash flows. We need to discount each of these cash flows using the 10% required return as our discount rate. We'll get $1.20 from this stock next year. What is that worth today? Discounting 1 year with the 10% discount rate gives us a value today of $1.09. The value today of the second dividend is $1.14, and the dividend received at year 3, $1.59, is worth $1.19 today. So far we have the value today of the dividends paid in years 1, 2, and 3. We just need to get the remaining years 4 until year infinity. Well, that 3339 represents the value at year 3 of the dividends from year 4 to year infinity. Discounting the 3339 back to time 0 gives us the value today of the dividends in year 4, 5, 6, all the way to infinity. And that turns out to be 2509. Adding these values together gives us a total of 2851. That's the value of this stock today. 2851 is the present value today of all the future cash flows this stock is expected to pay off. Now notice that we never added the dollar dividend paid at time 0. Why is that? The reason we ignore that dividend D0 is because it's already been paid out, so it's irrelevant to the value of the stock today. We're never going to receive it, so it has no value to us. The value of the stock is the present value of its future cash flows, D1 and every dividend afterwards.